Welcome to my class. Data transmission switching techniques. Data communication takes place between two devices that are directly connected by some form of transmission medium. This medium can be in the form of twisted wires, coaxial cables, fiber optical cable, microwave towers, satellites, etc. So data communication can take place between two devices that are directly connected by some form of transmission media, and transmission media can be these wires or these towers or satellites. Often it is impractical or uneconomical that two communicating devices are always directly connected with each other. For example, TV and remote control. Quite often, communication between two devices is achieved through a network of intermediate nodes. For example, here you can see that two persons talking to each other, and they are connected to mobile towers, and mobile towers are connected to mobile telephone switching office. So we find that communication between two devices is achieved through a network of intermediate nodes. These nodes provide a switching facility that moves data from node to node until the data reaches to destination device. Data transmission switching techniques. There are three different methods of establishing communication links between the sender and the receiver devices in a communication network, namely circuit switching, message switching, and packet switching. On these three different switching techniques, there are three different lectures. The third data transmission switching technique is packet switching. In case of packet switching technique, a message is split up into packets of fixed size, that is few thousand bits. The block of message to be sent is known as a packet. Along with the block of data, that is a part of the message to be sent, a packet has a header that contains the sending and receiving device addresses, number of current and last packet, etc. Look at this example. Here the sender intends to send a particular message. A message is divided into number of packets, and these packets are sent from the sending device to the receiver device. Look at into this particular case. Particular packet is sent from the sender device to a LAN switch. LAN switch moves it to the router. From different networks, it reaches to the receiver. This is the case of one particular packet. In the packet switching technique, the second packet may take a different path. For example, this green one, it is another packet and it is taking a different route. Now both these two packets have taken two different routes. Like message switching technique, the packets may be moved from the sender node to the destination node by store and forward method. The intermediate nodes store it for the moment till the path is clear. According to store and forward method, the packets are stored temporarily at the intermediate nodes for error recovery purposes and are routed to the next node based on an availability of free channel. The moment free path is available, till that time these packets are stored by the intermediary nodes. The actual path taken by each and every packet to its destination is dynamic because the path gets established as it travels along. Thus, there is a possibility that different packets of the same message can be routed across different paths leading to the same destination depending upon channel availability and the network congestion. What are the advantages of packet switching? Since packets are of small and fixed size, therefore the storage requirement for buffering the packets at intermediate nodes is minimal, as the complete message is not routed. Second, the transmission time taken for packets are less because the routing is done on packet basis and the intermediate nodes need not wait for the entire message to come. The third advantage is this technique is suitable for interactive or real-time application as the transmission is quite fast. Now the disadvantages of packet switching. In this technique, there is need to buffer each and every packet at different intermediate node and to reassemble the packets at the destination node. The resource overhead incurred to transmit every packet is high. Second disadvantage, there is no assurance regarding the time taken to transmit a message from its source node to its destination node, because the time taken for each packet depends on the route chosen for that packet along with the volume of data being transferred along that route. Look at one more example. In this particular case, the sender computer intends to transmit 5 different packets. The whole message is divided into 5 different packets and the sender computer intends to transmit all 5 packets. These packets will follow different path. You can see that this particular red line, it contains packet number 5. It has chosen a path from the sender computer. It goes up to receiver computer. The next one is packet number 4. The yellow arrow shows packet 4. It follows a different path and it reaches to receiver computer. The packet number 3, dark red arrow, shows packet number 3. It takes a different path. The green arrow shows packet number 2. Packet number 1, blue line, so you have seen that there are 5 different packets and they take 5 different paths, but they all move to receiver computer. In the packet switching, the whole message is divided into number of packets and these packets are then routed through different paths. All packets starts from the sender computer and they reach to receiver computer. Once they reach to the receiver computer, once again these packets are reassembled so that the receiver computer gets the information. This is packet switching technique. Thank you very much.